Hi everyone, welcome to part 2 of my lab here. I really apologize, I had to kind of cut that previous recording a bit short. So this is part 2. So we were on question 3. Now, what's question 3 asking? What type of IP addresses are currently assigned to the Tampa, Orlando, Key West, Daytona and Miami routers? So those IP addresses are IPv4 addresses. They're configured with IPv4 addresses. But the next question asks, what's the theoretical maximum number of unique IP addresses of this type, IPv4 addresses, that can be signed? Well, the rough estimate is 4 billion. So to be precise, the number is the way you calculate is 2 to the power of 32. Okay, so 2 times 2, doing that 32 times. Okay, 2 multiplied by 2, 32 times, which equals 4 times which equals 4,294,467,295 IP addresses. Okay, so due to the inefficiencies in allocation addresses, estimate that there are approximately 1.3 billion usable IPv4 addresses available. Okay, 1.3 billion usable IPv4 addresses available. Okay, but we've had a shortage of IPv4 addresses. Thankfully, we've been able to extend. And this is coming into question 5 now. Why is there a need to change this IP addressing? This method of IP addressing. Well, the reason is because basically we've had a short. Because of the vast increase in internet usage in the last even since the early 1990s, around probably around the early 1990s, I think. And then with the rise of the internet, the dot-com boom around about 2000, and subsequently smartphones, tablets with IoT, and we've had more and more devices need to use the internet. More and more IP addresses need to be assigned, and we've quickly run short. There's also been the way IPv4 addresses were allocated. We've not been the most efficient in how we've allocated IPv4 addresses. So we've come up with ways to help preserve, like NAT, for example. NAT's helped, network address translation. That's helped preserve IPv4 addressing. But ultimately, we need to change. We need to create a solution for this problem. The ultimate solution is IPv6. Okay, much longer IPv6 address, and there's many more. I mean, 4 billion sounds like a lot, but compared to IPv6 addresses, there's many more IPv6 addresses available for usage. So I'm just trying to display the answer, but it's not letting me display it. If we display the answer, okay, new method IPv addressing is needed because the IPv4 address space is being rapidly exhausted. Address conservation techniques such as classes interdomain routing, variable length subnet masking, VLSM, and private IP addressing combined with network address translation, NAT, and port address translation have extended the life of IP addressing long beyond initial predictions. Even so, the growing number of internet users is rapidly exhausting the remaining available IPv4 addresses. A new IP addressing technique that allows for much larger number of addresses is needed to meet the increasing demand of internet users and the growth of new internet-enabled devices such as wireless phones and other handheld devices. Okay, so that's task 1 there done. We'll be moving on to task 2 and task 3. So I will see you in a part 3 of this lab series. I will see you in part 3, and we will do task 2 and hopefully task 3 all inside that third video. So thank you so much for watching, and I'll see you in the next video. Thank you.